Good morning students, welcome to today's session. So in the last class we have seen what is probability and some types of sums under the probability and also formulas, everything. I hope every one of you understood the topic probability, and today we are going to continue that chapter alone. So before going to today's session, so we are going to recap just the formulas and some properties of the probability again. Alright. Then after that we are going to enter into today's session. So look at the formula. So the formula of the probability is nothing but P of P equal to number of favorable cases divided by total number of cases. So in notation also we can define the formula, that is n of A by n of S. So before entering into the solution of the probability sums, first we have to identify the number of sample spaces and also number of events. So that both terms are very important when you are doing probability sums, because the formula is based upon that only. So here n of A stands for number of elements in the favorable cases, and here S is nothing but number of sample spaces, that is total cases, right? So that we need these two cases in every questions under probability, right? And also we can define all the events in alphabets, that is A, B, C, like that, or E1, E2, E3, etc. That is E1, 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 etc. like this. Okay. So however, before going to solve the probability sums, you should write the necessary steps. That is, you should write the first one as the sample space, that is the possible cases of the sample space, and next one number of sample space, that is second step, and the third step you should define the event first. So three questions are there asking in the question itself, means we can write first start from E1 onwards. So E1 equal to the event of, and E2 equal to the event of, and E3 equal to the event of according to the question. And then you have to find out the number of elements in the events. Then we have to divide that number of event by the number of sample space. So that is a procedure to find out the answer for every probability questions. Okay. So next we have seen so many properties. There is three properties in the last class. Okay. So let us recall the properties now. So sum of the probabilities of all event of an experiment is 1. In the last class itself, I have explained how it is equal to 1. Okay. Suppose one experiment is there. If you want to find out the probability of each event of the experiment, suppose it contains only 4 questions, okay, or 4 events. So we are going to find out the probability of all the 4 events, and finally if we add up all the 4 probabilities, we will get 1. Okay, so that is nothing but sum of the probabilities of all event of an experiment is 1. Okay, and that is, it is denoted by the formula P of E plus P of E bar equal to 1. Okay, so here E is nothing but the event, the particular event. Okay, the E is nothing but the particular event, and E bar is nothing but the opposite event of E, or the remaining set of event of E, or we can call complement of E also, right? So complement of E is nothing but E bar, or you can call not and E, right? So some set of events are there for the particular experiment, means we can divide it into 2 parts. One set of part we can call as E, and next set of part we can call as not E or E bar, or complement of E, you can say, or you can call at any. Okay, nothing, right? So next probability, the next property, the second property is nothing but the probability of an impossible event is 0, and the third one limitation of the probability, because impossible probability is 0, that is impossible event. Probability for impossible event is 0, and the probability of the maximum, that is the maximum value is nothing but 1. Okay, so we can define the statement like this also: the probability of an impossible event is 0, and one more statement also there: the probability of sure event is maximum 1. Okay, maximum 1. So these are the important properties. So these are the important properties on probabilities. Okay, so next we are going to see one example. So look at the example. So two players, Sangeeta and Reshma, play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62, and what is the probability of Reshma winning the match? Okay, so look at the question here. Here two persons are there, that is Sangeeta and Reshma. They play tennis match, right? So what is 0.62 given here? The probability of Sangeeta, okay, the probability of Sangeeta winning the match, right? So what is the question they're asking? The probability of Reshma winning the match. That is the question they're asking, okay. As I told you earlier, that is before going to solve any probability sums, first you have to identify or you have to find out what about the total cases or sample spaces and next events. Okay, these two are very important. So here the total number of cases nothing given here. Instead of that 0.62 probability they are given. Okay, so here only two events are there. Okay, what is the two events? And before seeing the events, first we have to check what is the experiment here. So experiment is nothing but, so that is playing tennis match, right? That is experiment here. So what are the events here means winning the match and losing the match. These two are the events here. Okay, so what is 0.62 now? That is the Sangeeta winning the match is 0.62, but they are asking what about the probability for the another person, that is Reshma winning the match. Okay, look at the example, that is look at the solution now. We have to define the event first, right? So E equal to the event of Sangeeta winning the match, right? So that is the event. First we define the event now, and P of E already given us 0.62. The probability of Sangeeta winning the match is 0.62 already given. Okay. Now we are going to define another event E bar. So E bar means what? Complement of E. So complement of E is nothing but the opposite event of E, right? So what is the event of E? Sangeeta winning the match. And what about complement of E? Sangeeta losing the match. That's it. Okay. So the probability that Sangeeta losing the match is nothing but E bar, or suppose Sangeeta losing the match means what about the meaning here? Reshma winning the match, right? So this question only they are asked here, right? So we are going to find out the probability of E bar only, right? We know that here P of E is here and P of E bar we are going to find out. So both are connected by one formula is the third property. P of E, that is what is the third property? So P of E plus P of E bar, right? So P of E plus P of E bar equal to 1. We already know the what is it, property. That is the third, so the first property, that is total probability of an event equal to 1. So that one. So from here P of E equal to P of E plus P of E bar equal to 1. So from that property P of E bar equal to 1 minus, because total probability is 1, right? So 1 minus 0.62 equal to 0.38, right? Or we can just go through the property again. So here P of E plus P of E bar equal to 1 given, right? The first property. P of E plus P of B bar equal to 1. So here P of E only they are given as 0.62, okay? So if you bring it 0.62 right hand side, it will become 1 minus 0.62. So P of E bar equal to 1 minus 0.62, so equal to 0.38. So here the total sample space not given here, but instead of that we have used the property. Okay, so like this the questions are given means, that is it is not possible to find, that is identify the total sample space, or it is not given means you can use the property. Okay, with the help of the property you can find out the value, right? Then see the next example. Savita and Hamida are friends. So what is the probability that both will have different birthdays and same birthdays? So we can ignore the leap year, right? So in leap year 366 days will come, and non-leap year 365 days only. So they are asking to consider non-leap year, that is out of 365 days. Okay, so here also, that is the total cases not given, but we are going to find out of 365 days only, so that here the total sample space is nothing but 365. Okay, so look at the solution here. So let A equal to the first. What is the first question? The event of having different birthdays. Okay, so this is the first event, this is the first event, and this is the second event. So first event, second event, you can take E1, E2. Okay, likewise in order. But here I took AB. You can take anything. Okay, any letter you can define, right? So let E equal to the event of both having different birthdays, right? So here we need total sample space, right? So let us take that A equal to 365. Okay, before that, so different birthdays. For example, their birthday days are different, right? So if you consider Savita's birthday means what will happen? So remaining 364 is nothing but any one of the day of another person's birthday, right? If you consider Hamida means, if you consider for example June 21, okay, so June 21 is a birthday of the first person. Okay, what about the birthday of the next person? That is different definitely according to the first case. So the remaining days is nothing but 364. So out of 364, definitely one day is the birthday of the another person. Okay, so we can subtract the birthday of the first person here. So 365 minus 1 equal to 364. Okay, so that is the possible cases here, right? So the first person having the birthday on June 21 means the remaining 364 are the possible cases to the next person, right? So that we can take here 364 is the total possible cases. Okay, then sample space is nothing but 365. So the answer for the first question is nothing but 364 by 365 for different birthdays. What about for same birthday? So same birthday, for example, the same, I can take the same date, June 21. So both are celebrated their birthdays on the same day, that is June 21 means that is only one day out of 365 days. So you can take that one day is the favorable to both of the persons. So we can take the total event is nothing but 365 and 1 is nothing but the favorable cases. So the answer is 1. So that one, that is they have the same day, only one day. So that the numerator will be 1 here. So 1 by 365. Or you can use the property also. That is in the last problem we have used P of E plus P of E bar equal to 1. So in that case also you can use. Okay. So 1 minus, so 364 by 365 is there. So you can substitute inside of that one and subtract it. So whatever it is, here you can use either through the property or you can use the logic also. Okay, so they have the same birthday means only one day favorable to both of the persons, so that you can take 1 as the numerator, so 1 by 365. So they are different days means, so the second person's birthday, it may be one of 364 days, that's why it is in the numerator, right? So that is the solution for the second question, right? And so suppose if they are asking to use the properties means we should use the property only here. Okay, but here there nothing used, that is you can find out the answer, that's it. Okay, so you can find out the answer through the property or through the logical one. Okay, so this is a procedure to find out the probability of the given events using either property or directly. Okay, directly by using the logic. Okay, so let us continue in the next slide or next video.